Yeah, I was supposed to register 2 days ago.
All right.
I forgot.
Hey everyone, this is our, what is it, I don't know, fifth, last meeting of the quarter. Today we have with us, Dawn, who's graciously come to present to us about grounding. Do we have any announcements first, Kevin?
Seabrook celebration, going on July 5th, right?
June.
June.
June 4th, right?
You can come in July if you want. But yeah, June 5th, that's the Sunday before finals. We'll have some cake and food and barbecue and stuff. And we'll be doing some activities and stuff to celebrate. At the end of the year, we've done a lot. And we just want to thank everybody who has been a part of this wacky establishment. So join us on June 5th at 12.
Oh, here we go, get more people. The only other thing I had was we have the JPL meeting we're presenting at tomorrow at 12 p.m. Anyone's welcome to join. I think we have a link in our Discord. I think Andrew sent it out in the legal email, I'm not sure. But if not, yeah, we can send it out again. All right, I think that's all for announcements. Without further ado, Dawn, take it away. Whoops.
I'm not gonna clap for him or something.
Yeah,
Okay, let me just,
all right.
okay, let me, quick introduction. We'll talk about the basics of grounding for the amateur radio operator. Grounding is a fairly simple concept, the application where it can go awry. And unfortunately, it's one of those things that it doesn't always affect normal operation. You don't find out that it's not done right until there's a instance where it's called upon to do its function and fails. So it's important to pay attention to the details of it, which are a few, but important. So with no further ado, I guess if we can get the share, okay. I guess somebody, let's see, okay. Is the PowerPoint coming across?
Perfect, we can see it, yep.
Yep.
Okay, great. Key points will be grounding versus bonding. They're two separate things, interrelated sometimes, but very, very different, although many times people confuse the two. We'll talk about the function of grounding and bonding. We'll touch on lightning protection and some of the specific requirements for amateur radio stations. A couple of definitions that are handy according to the National Electrical Code. And any reference to the code is 2017 edition, which is what not only in New York is the current one, but in California as of January of 2020, I guess, was adopted. Ground is just earth. Grounding is a connection to earth. Bonding is connection to establish electrical continuity and conductivity. So you can have things that are bonded together, but not grounded. You have things that are grounded, but not bonded. And you have things that are both bonded and grounded. Functions, voltage stability, which is mostly a utility issue to provide. It's easier for them to provide a stable voltage to the customers with central regulation if it's a grounded system. A lot of European countries use ungrounded systems and use localized voltage stabilization. Most importantly for the person at the end of the transmission line or distribution line is that in your house or building, it provides an effective ground fault path. This is something, the definition of the code about it. This is a path that you provide. So if there is a ground fault, it has a direct path back to the protective device, and it allows the fault current to trip whatever protective device you have there. And lightning protection, ground is to provide a way to deflect the strikes safely into the ground to avoid it entering buildings or striking equipment. A direct hit, if you have a direct lightning hit, most amateur radio installations probably won't be able to protect themselves against a direct hit completely unless they want to spend an inordinate amount of money. Radio stations, commercial stations, many times they take direct hits and keep on operating. They spend a lot more money because they have a lot more money at stake. Most of the time with amateur concerns, it's indirect hits, either nearby or in some cases, another item. You might get a hit to, say, the ground near a tower. If you take a hit by the tower, you can probably protect against it getting into the house, but you're going to probably lose either an antenna or some of the feed line and so forth. What ground you won't do, it's not to prevent electrocution, and electrocution is fatal. Once you're electrocuted, you're gone. Ground fault protection will protect against that. We'll talk about that a little. Some of the codes that would apply when you're installing grounding for a facility, state codes, the National Electrical Code, and specifically as it's adopted by your state or local codes. And the local codes could be a city or town or a village. And generally they can impose more strict requirements, keeping in mind that the National Electrical Code, NFPA 70, is really a minimum specification. So when possible, you want to exceed it, do above and beyond. The materials of concern are the electrodes, the ground system, the conductors, both to tie ground systems together and to connect the rest of the equipment to it, the different types of terminations. One of the main goal is to have equal potential bonding to a grounding connection, to a single point ground, which we'll talk about. It doesn't necessarily mean you have to have a home run from every location to one point, but all equipment within a specific area close by to each other should all be connected, bonded to the same ground or ground. If you can have sometimes people put a ground plate, they put a ground bus, and then that gets in turn connected ultimately to the ground connection in the service panel to the structure. And the basic requirement is there so you can minimize potential differences between different equipment. Sometimes, even if you don't have a lot of current potential, if you have a high voltage potential difference between two pieces of equipment, it can cause breakdown and sometimes initiate current flow from other, like the 120 volt power connections, if it ionizes the air nearby and provides a conductive path. So even a slight difference in potential can cause a breakdown. We talk about a single point ground, and just as a very crude illustration of a structure, and there's a ground electrode system that ultimately is the point that it wants to get to. You can have for the building a main ground panel or bus, typically in your panel, and every room, every area that's a contiguous area is going to have the equipment bonded together and then fed ultimately to that point. And this provides the fact, it's like the birds on a wire. They go up and down together with the voltage on the wire. They don't have a problem. So if all the equipment sees an increase in potential together, the differential difference is zero. Grounding gets involved with as far as preventing excessive current flow through the human body if there's an equipment fault. Now, human tolerance to electric current, based on a lot of the work by Charles Dialzel, who also, it was the father of the ground fault circuit interrupter, tested people with different weights, male, female, and he used cups of rice and let certain values of current flow through them to see where it was either pain, with slight feeling or painful. problem gets to be where you have an overlap between the, what's just a discomfort and what can be painful, which depends mostly upon the weight of the person. And this was kind of a tabulation to give you an idea of the values that he found. More clearly, if we look at it this way, and you can see the problem is the overlap, where here, for a 160-pound person, this is harmless. You know, you may feel a tickle, but it's not going to do much. But for the lighter weight person, it's considered a painful shock. It will, if it's within that 4 to 6 milliamp range, a ground fault circuit interrupter will trip. But even though it's not going to be fatal due to the current flow, if you're standing on a ladder doing some work and all of a sudden you get that painful jolt, it can cause you to fall off the ladder and hit your head, and dead is dead. So one must be careful, not thinking they're totally safe. Well, the ground fault interrupter is going to protect me. It may not, if protect you from being jolted by the electricity and then falling off of a ladder or falling back into something. So that overlap between what's a harmless tickle and a painful shock is a very important concern. You can get impulses coming in from many places. You can have a strike to a power line that feeds your structure. You can have direct strikes to the structure. You can have strikes to trees nearby, equipment that's outside, HVAC units and so forth. You can have strikes right to the ground, and then you get a ground potential rise that if you have equipment there, it can flash over to. You have incoming lines, cable TV, phone, and even if you have fiber, as long as it's a totally 100% dielectric fiber, you're okay. But if it's, sometimes they have a conductive messenger in the fiber, and that can also be a path into the house. So what you want to do is prevent the voltage events from coming into the house. You want to provide it a path. It's easier for it to find into the ground. Outside the building, you have the antenna grounding, tower grounding and bonding, the building itself. If you have metallic parts of the building, siding, things like that. Proximity to other metallic objects. If you have a ground conductor and it's running adjacent to, say, a downspout or a chain link fence, you don't want to have it arc over to it and create a problem further down the line. So then everything has to be bonded together. And sometimes if you have a very long fence line that goes out into near other people's property, it would behoove you to have a mesh network around the fence itself to lower the gradient that from the step and touch potential, which we'll mention a little later. The main part of your outside ground plan is going to be your grounding rods, the electrode system, which can be a ground rod, it can be plates, it can be pipes, it can be a number of things that we'll mention. Very important to protect any conductor coming into your structure. It could be antenna, power, telephone, data, and so forth. To provide for that, the newer, the recent codes require a device, an intersystem bonding device that connects to the ground electrode conductor, and then you can tie in your grounding connection to the auxiliary stuff, whether it's cable or your ham station or whatever. And this is the cover removed. They have them different sizes, different number of ports in the terminal block, and the port for the ground electrode conductor is an open-ended one that you can slip around an existing ground electrode conductor. Basically, your grounding system consists of ground electrodes, the conductors, the ground electrode conductors, as well as the grounding conductor. There's always a discussion about flat conductor versus round conductors. The real simple answer is theoretically, a flat conductor has benefits for a high rise transient. Practically speaking, if you don't have it installed without any sharp bends and no creases, and that you have exactly the correct terminations for it, it may not be any better, it may be worse than a conventional round, either solid or stranded conductor. Ground clamps and attachments, welds. I've seen people that spend many dollars on towers, the tower itself, the foundation and the antennas, and then they connect the ground conductor to the tower leg with a radiator hose clamp from an auto parts store, which in case you do take a big hit is not going to do an awful lot. So you want something that's listed for the purpose, that whether it's UL or ETL, that they've tested it and found it to be suitable. It's all about the connections. Very important item. If you don't have good connections, if you don't make sure that they're solid, the system won't work as it's intended. And you always want to have a grounding provision at the entry to the building. The idea is provide a path for the ground, for the stroke, and then make it difficult for any residual to get into the structure. The ground electrode is very simple. You have the conductor, some kind of connector, and the electrode itself. Very basically looking at, you have these fields of around the ground electrode, which will illustrate why, although the National Electrical Code only requires a 6-foot separation between multiple ground electrodes, you really should go like twice the ground electrode length. Otherwise, you're kind of wasting, if they overlap, you're not getting the full benefit of both electrodes. So that's why if you're going to increase the ground electrode capacity, you want it deeper, gives you more benefit than more if they're close together. If you have enough room to spread them out twice the electrode length, then that certainly will be probably the easiest way to do it, especially if you're in an area with difficult to penetrate terrain. These clamps are typically the type that are used. This is not a good illustration, only because there's a sharp bend in the conductor, but you don't want to use a hose clamp or something like that. You want something that's listed for the purpose and it'll be marked on the device itself. The electrodes themselves, if it's a rod, has to be a minimum of 8 feet in contact with the earth. It can be vertical, it can be horizontal if it's at least 2.5 feet down. It can be angled up to 45 degrees if you're in an area where you just can't get through. There may be underlying rock. That always presents a problem. In the worst case, if you're in a real rocky area, you have to go to an artificial ground electrode where you have to bore a hole and put in a chemical ground rod where you put in a sleeve and then you fill it with a salt that has to be kept moist, and the ground electrode goes into that. Again, the 6-foot separation is just the minimum. Twice the rod length is preferred for more effective use. There are something called concrete enclosed electrodes, or UFA ground. The rebar in a structure can be used under certain circumstances, or it can be a length of copper wire. It needs to be covered by 2 inches, a minimum of concrete, and it can be 20 feet or more of bare, galvanized, or conductively coated sheet, minimum 1/2 inch diameter, or 20 feet of bare copper wire, 4-gauge minimum. The rebar ties that tie, if you have rebar that's tied together to form the 20 feet, the ties are considered suitable to keep it close enough, because there's a lot of conductivity in the concrete between the rebar. Epoxy coated rebar is not used for this because it would be insulated from the concrete. Concrete's a pretty conductive material. There are other ground electrodes that can be used, underground water pipes, if it has 10-foot earth contact, and as long as you're not connected to it more than 5 feet from the entrance into the building. Some metal building frames can be used as a ground electrode, depending on how much of it is in contact with the earth, or if the bolts that attach the structural steel are connected to a concrete encased electrode by one of the approved means, welding, exothermic welding, or any approved means. Rod and pipe electrodes, pipe or conduit, 3/4 of an inch or more would be suitable. Stainless steel, galvanized steel, or copper coated steel. Now, this is subject to your local soil conditions. I'm on the East Coast, on Long Island. We have the soil around here. If you put galvanized steel in it, it's probably not going to last too long, but the copper coated steel seems to have a very long lifetime. Some places where the soil is really a arduous type composition where nothing wants to live in stainless, you get a little less conductivity, but it may hold up a little better. If it's a listed ground rod, the 5/8 inch minimum doesn't apply because they're tested for the equivalency as they're manufactured. Plate electrodes, again, 2 square feet of surface area, but depending on the material, if it's steel or iron, 1/4 inch. If it's copper, a minimum of 60 thou. Ground of resistance testing. This can be an expensive proposition. And usually this only occurs for critical applications like cell sites and so forth, where they have to achieve a very low ground resistance. But it's basically you inject the current through the ground soil and you move the movable electrode in, towards the far electrode, and you keep making voltage measurements. And when you reach that flat part of the curve, when you plot it, that's considered the measured resistance of the ground. There's a wide variation in resistivities of different kinds of soil and composition. As you can see, it's a very, very wide range. One of the worst is like, again, on the South Shore where I live, where it's all sand, and sand is basically silicon, excuse me. It's glass, good insulator. If the tide comes in and you get it washed with salt water, you might work for a while, but it's not something that provides a real good conductivity to start with. The code only requires 25 ohms for the ground electrode, or you have to add an additional rod. No requirement to measure it after that. This may be adequate for most amateur facilities. Most commercial facilities have a requirement for much lower ground resistance. It used to be you put one ground and says if it didn't measure 25, you put a second one. Starting with the 2011 code, it just says install 2 rods unless you already can show that the ground resistance is less than 25 ohms with one installed. This was just a recognition of what was normally followed in the field, because it was cheaper to have an electrician put in 2 ground electrodes while he's there with the hammer than having to call someone else to do a resistance measurement and then have to drive the ground rod in anyway. It's all about the connections. It can't be stressed enough. Again, I mentioned if it's an appropriate connector, it'll be identified. On the other side of this, you'll have some certification, whether it's UL or ETL. They'll give you the wire gauges that it's good for and so forth. Now, most of these, and you'd have to look at the conditions of listing, are listed for use in direct burial. Keep in mind, though, if it's direct buried in the soil, it's going to behoove you to have to check on the condition of it, or you can kind of protect it when you first bury it. You can wrap it and seal it, and this way it'll function a lot longer. Put some anti-ox paste in there. These are some mechanical connections that are once you hammer it in, it's going to swedge it into place and make a connection. But if you have to remove it, you're going to have to cut it off and hopefully have enough slack to accomplish it. But these are a quick way to provide a very sound connection where there's no question. You don't have to measure torque values of a bolt or anything else. Crimp connections. This is an illustration of a cross section of a crimp connection, but you can see it's not a very good one. You have a lot of interstitial spaces between these strands, and that eventually you'll get corrosion and in there, and it could fail. This is what a crimp connection looks like when it's fully compressed to what's called a gas tight joint. There's no porosity there. This is probably the best way, a so-called CAD weld or exothermic weld. The code recognizes that as equivalent to a solid conductor. And it's a fairly controlled process. You know, the old style, you had the graphite molds, you have a powder in there with two different kinds of powder. You put the items to be joined, whether they're the two conductors or a conductor and a ground rod. And you light it off, a lot of sparks, and then you form that joint. Most of the amateurs these days use a one-shot. It comes, it's a ceramic mold. You use it, and then it's done. If you're going to do only a few connections, this is probably an economical way to go, because the graphite molds are very expensive. And they require more in the way of specialized clamps. Key to the grounding within your structure is the main bonding jumper. And it basically, that's where your ground and your neutral connection get tied together from where the service comes into the house or building. And it's important that that connection only be made at one point, and that's at where the service comes in the service panel. If you run what some may call a sub panel, more probably just another distribution panel or lighting panel, you can't have the neutral bar and the ground bar connected together in those. The kits those have insulators to keep the neutral bar separated from the enclosure, which the ground bar will be tied to. The main bonding jumper can be a screw, a bus bar, or a cable in a panel. In this case, you have this bus bar that goes between the two, the neutral and the ground bar. Here's a case where you have a separate main breaker. So you have your ground bar here. This is typically what you see a lot of times. This green screw is, in this case, your main bonding jumper between these two, the neutral bar and the ground bar. Any threaded connection, it requires at least two machine threads engaged or secured with a nut. There are several acceptable types. Machine screw is acceptable. A thread cutting machine screw is acceptable. A tech screw or a drill point screw is not. If it's a coarse thread screw, that's not considered an acceptable grounding connection, nor is a sheet metal screw. If you're going to run your grounding conductor through a ferrous metal conduit, one thing you have to do is bond at each end of the conduit, bond the conductor to the conduit. The reason you do that is the single conductor inside the conduit is going to form a choke. So if you don't bond them together and there's a heavy current flow, it's going to restrict the current flow. And in fact, you'll get a heating effect at the where at the ends of the conduit where it goes into the box, and you're going to get damage to the equipment. This is just one way you can accomplish that. If you have a conduit, you can have the bonding of that together. If you have your ground electrode conductor is passing from your, say, your service panel out to your ground rod, they do have bushings that screw in and will make intimate contact with the conductor and provide that bonding to the enclosure. Likewise, if you have a larger grounding conduit, conductor and conduit, a fitting like this can be used. This is an illustration of pretty much what not to do. Although this is a PVC conduit, it doesn't have to be bonded, but they take two very sharp bends with the conductor, which again acts as an inductive reactance and will delay the flow of the impulse, the surge current. And it looks, can't see it as well here, but the pipe had none of the coating removed. They were just relying on some of the serrations and that clamp to go through it, which isn't always effective. This would be the typical clamp for attaching, if you were using a water pipe, say, as a ground electrode, and you attach the clamp around it and then put the conductor in the upper port. This is not the kind of clamp you'd use for a ground electrode unless it's also listed for that purpose, and it would indicate somewhere either probably not on the part itself, but you'd have to look at the box it came in or the stuffer sheet that comes with it. If you're using reducing washers in a panel, you have to bond around that again. You can't rely on that washer to provide the continuity of the ground connection because of the paint coatings and so forth. You look at this and you wonder, well, hey, someone thought ahead, they're going to provide extra cable for the future. But if that grounding conductor took a hit, that would be whipping all around and probably damage or even break. There's tremendous mechanical forces at work on the conductor when it takes a heavy current load. So you don't want to have an installation, something like this. You cut it to length, the required length, and you clamp it securely. If you have a pipe that you're using and there's something like a water meter or other replaceable device, you always want to bond around it. However, the interesting thing about this location is they started out doing the right thing, but then if you look over here, there's a gasket between the two flanges, and unless they put some kind of an insert through the bolt holes and stuff that would provide continuity, they very well may have isolated this pipe from the rest of the section. Okay, another area of concern that is that all metal piping, including gas piping that could become energized, has to be bonded to the service ground. And although you can't use gas piping as a grounding electrode, the gas pipe bonding connection can be achieved in two different ways. If you have a piece of, like say, a clothes dryer where it's connected to the gas supply and you have a three-pronged plug, that grounding electrode conductor in the three-pronged plug will provide this bonding connection. If not, you have to provide an auxiliary connection. Now, National Grid is our local gas utility. Your local gas utility would have equivalent to their Blue Book that gives requirements for the grounding and bonding when you have corrugated stainless steel gas piping. This varies from location to location. Currently in New York, you cannot use the fitting or the tubing itself for the grounding connection, the bonding connection. Other localities may allow that because some manufacturers have come up with connectors that are tested to be suitable for that, but you have to go by whatever your code, your local or your state code allows. Yeah, and then there's some requirements for that. Basically, it's it has to be a pipe that's steel or wrought iron. Again, in this locale, the hex nut or the tubing cannot be used as the attachment point. It has to be a separate short nipple that's where the gas service comes into the house. The other another area that if you're wiring up, say for your ham shack, there are different types of armored cable. There's type AC cable, which some people still call BX, which was an antiquated designation for an older style, and MC cable. And keep in mind the grounded conductor, not the grounding conductor. The grounded conductor is the one that's intentionally grounded or sometimes called a neutral. and the equipment grounding conductor connects normally current, non-current carrying parts with the grounded conductor, the ground electrode conductor, or both. This is the green wire. The equipment grounding conductor is the green wire. The grounded conductor is typically a white or neutral if it's wired correctly, following codes. Type AC cable will always have this little drain wire. It's usually an aluminum drain wire that bonds against this these corrugations and reduces, eliminates the inductive effect. Type AC cable, it's always appropriate and accepted to use the armor as the grounding conductor, as long as you're using the appropriate connectors where it comes into the box. Type MC cable may or may not have that bonding, that little drain wire. If it does have it, it'll be marked as suitable, the armor is suitable for use as a grounding conductor. If not, you'd have to have the separate grounding conductor, green wire within that. This drain wire, by the way, does not usually go into the box. It gets folded back. And it can be either under the little plastic bushing or over the plastic bushing. Most people do it over so it keeps the bushing from falling off. The big difference otherwise is that AC cable is very limited to the number of conductors and the sizes, where type MC cable, you can have many conductors and practically speaking, have almost no limit, 18 gauge to 2000 MCM. The grounded conductor or neutral, depending on your system configuration, if it's a three-phase Y system, it's typically the midpoint here. You can have a corner grounded delta system. So you usually find that in industrial plants. You can have a so-called high leg delta where the middle of one winding is grounded, and that forms your neutral, and it gives you your 120 and for a 240 volt system, will give you 120 between these 2 points, 240 between the phases. The high leg designation is to indicate that between any of these other points, between this point and this point, you're going to have much more. You're going to have a higher voltage, so than the 120. So you can't just go between one of those points and the neutral and expect to run 120 volt equipment off it, or else it'll fry. The receptacle grounding, sometimes people will get into arguments about which is appropriate with the ground pin down, the ground pin up. There's nothing in the code that indicates a preference. You may have sometimes certain facilities where the owner specifies it be a certain way, and then that would have to be abided by if you were doing something in a building like that. Each one has its pluses and minuses. The ground pin on the top, the feeling is that if you have a metal cover plate and it comes loose and the plug is out a little, it'll hit the ground pin first and won't hit the the other conductors. The ground pin on the bottom, some feel it gives more mechanical support to the plug, especially if you have a little wall wart power supply. But again, no code requirement for that. And this typically your receptacle wiring. If you have a plastic box, you'll have the ground wire coming right out to the green screw on the receptacle. If you have a metal box and the ground connection is made to the box, and the receptacle device is a so-called self-grounding where it has a contact on it, when it goes against the box, it makes that contact through the yoke. Just a quick mention of GFCIs. After 2014, the code added pretty much everything in a residence has to be GFCI protected. There are a few exceptions, but most, not too many. And in 2020, they included 125 to 250 volt receptacles, which was before that limited only to 125 volt and below. But these are all the typical places, and some of them, like basements. You may have a basement that you're going to use as a ham shack, where it's not intended as a habitable space, but yeah, then you have to have GFCI protection, which is a good way to go anyway. It's well worth the few bucks extra to have that protection. This is what the inside of a GFCI receptacle looks like. There's electronics in there, and if, as you may know or will know, if you don't already, electronics has a lifetime. There's a bathtub curve. You have the infant mortality, you have its lifetime, and then you at the end of life. So they do fail, and for many years, people would install them and never check them, and then they realized they didn't have any real protection. So now the devices are supposed to be, you're supposed to every 6 months hit the test button, which is really the only way to adequately test them and see if they trip and then reset. Newer designs were designed to be fail-safe, where if you test it and it trips, if it's not working right, it won't allow you to reset it. And real new models now, some have self-testing where it keeps testing itself, and if there's a failure, it'll enunciate. And this really comes into play for things like where you have receptacles behind, say, a refrigerator, and it's not easy to get to. Technically, they're supposed to be readily accessible. Okay. Some houses will have the GFCI protection at the breaker panel. And why do you have an equipment grounding conductor? Basically, if you have a ungrounded metal enclosure on a grounded system and you touch it and there's a fault inside, you're going to be part of the return circuit, especially if you're standing on, say, a concrete floor. If it's a grounded system, most of the current, the fault current, will be diverted to that ground conductor, the grounding conductor, through the established ground fault path, the intentional ground fault path, which allows the circuit breaker to trip. Otherwise, there may not be enough current to flow to trip the circuit breaker, but there'd be enough current to flow through your body with the ungrounded connection to cause fibrillation. Step potential, again, this generally is something that's encountered out in the open, where there's either a nearby strike or a piece of equipment nearby. There's a ground potential rise from that strike. And depending on how far apart your feet are and the ground potential rise magnitude, you may feel just a tingle, or you could get a fatal shock. Many years ago, I went to a seminar, and one of the gentlemen there had done a lot of work building substations in some of the underdeveloped countries. And he said the one thing he learned was, if you're in the substation and all of a sudden the hair on your arm stands up, he says, just get on one foot and hop away as fast as you can. And it's pretty good advice, because this way, at least you eliminate the step potential. Touch potential is very similar, it's just that now it's between your arm and your legs, forming the circuit. The bad thing about that is that path will go through your chest cavity, so it's more likely to result in fibrillation. Important things to consider with grounding is you want to prevent the disconnection of the parts, and you want to make sure that all of the adjacent items are equipotentially bonded. Sometimes people will put one ground stud and put 3 or 4 or 5 terminations on it. The problem with that is, if you have to remove one, the chances are you may not put the rest of them back, or not all back, or not correctly tighten afterwards, and then you're reducing the protection. You're eliminating that grounding conductor. So you want to have, if you have multiple grounding connections in one piece of equipment, in a panel or something like that, you put a terminal block where you can have each conductor going to a separate port. So if need be, you can remove one if you have to, and not disturb any of the others. Antennas and RF grounds, strictly from the performance, the ground plane or counterpoise can be smaller gauge wire than for protective grounds, but ultimately, since they're all going to be tied together, and since the antenna ground then will share some portion of a large fault current, you could end up damaging if you have a very fine gauge wire for your ground radials. So you best not to undersize that. Also, while cross-connecting of the radials from an antenna, say a ground-based vertical, don't affect your propagation pattern too much. They will help to even out the ground potential rise if there's a hit. And again, this is more of a concern if you have a real, like, say you have a 160-meter vertical, using tower sections that may be more likely to take a hit. You like to even out that ground potential rise. So if you're standing nearby when it gets hit, you don't have an excessive step potential available. The National Electrical Code does have some requirements for amateur installations, which I mention only because you could run up against this with a local inspector. It's largely open to interpretation in some cases. Most people kind of ignore it, but it's something that if you did have an event where, say, you had a house and there was a fire due to a lightning strike and you had antenna leads coming in, an insurance company may say, well, look, you didn't have it installed in accordance with the code. Chapter 8, Article 800 of the code addresses the communication systems, and subset of that, Article 810 covers amateur radio as well as citizens band installations. Okay, they have sections of transmitting and receiving equipment, antennas. They include verticals and wire antennas also. The Article 810 talks about grounding of towers and masts, and this is a point where, again, people say, "Oh, my tower is 150 feet from the house. I don't have to connect it to the ground system. I don't have to bond it to the service ground." Not according to the code. You do have to have it bonded all back to the service ground. And although you're not going to get tremendous current flow from a lightning strike over that ground wire coming from the tower hundreds of feet away, the idea is to equalize, again, the potential differences. The important, as I said, ultimately everything has to be tied back to the service ground. And the code talks about separation distances between antenna feed lines and power conductors. There are requirements for antenna discharge units, which in some cases are not always available in the configuration that will be needed. But it's not the only section where the code requires things that aren't commercially available. It talks about the spacing of feed lines, size of the feed line conductors, and the grounding and bonding conductors. And let me go back to that one. No mounting antennas to service masts. The service mast, where if you have a piece of conduit sticking up to the roof or on the side of the house where your electric service comes in, you'll frequently find people attaching other things to it. The telephone company does it sometimes, the cable company. Some people mount TV antennas there. Strictly a code violation, and it's not good practice. The antenna lead and surge protection, again, Article 810.6, must be listed. And when it says it must be listed, it has to be something listed by a national recognized testing labs, UL, ETL, one of those. It has to be connected between the conductors and grounded shield or other ground conductors, to be grounded with a bonding conductor. And if you have that intersystem bonding device, you would connect it to that. It does give choices. It's not the nearest service ground, the service ground, grounded interior water pipe, ground electrode conductor. Again, you're better going right to the service ground. Material requirements: hard drawn copper, bronze, aluminum alloy, copper clad steel, or other high strength corrosion resistant material. For lead and lengths less than 35 feet, medium drawn copper is accepted. Again, I don't know anyone personally who's ever had an electrical inspector question the size of their antennas, usually because the antennas are not installed at the time a house is inspected. If it's being built. If you're doing renovations in a house or a building, and it was significant enough that it needed a reinspection, the presence of antennas and the lead-in conductors and so forth can raise a flag for the inspector. And the local inspector is kind of the god. He has the last word, the local authority having jurisdiction. Again, limitations about not crossing over open electric, light and power conductors, has minimum clearances. And you want to avoid any crossing under or over of any of the power lines if they do occasionally come down when they're not supposed to. Splices must be mechanically secure. An approved means, and solder connections are never considered a mechanically secure connection. You can use like a Western Electric splice where you have the opposing conductors, wrapped around the other one, and then you can solder it for additional conductivity, but it's that mechanical wrap that's providing the mechanical security. Okay, grounding, mass and metal structures supporting antennas to be grounded. One thing that of interest about Article 800 in the code is it's one of the few articles where the requirements in the first 4 articles of the code don't necessarily apply unless specifically called out in Article 800. So they give a lot of specific information. Anyway, the grounding, and if the antenna and its related supporting structure are within the so-called zone of protection, defined by a 150-foot radius sphere, then it would not have to have the grounding, but you're better off having it anyway. I'll try to speed this up. The requirements for the grounding and bonding connectors, the electrode conductors, and they give a whole host of requirements to material. And again, aluminum conductors and copper-clad aluminum is never acceptable for direct earth contact or contact with masonry in moist conditions. The conductors don't have to be insulated. Mechanically secure, can't just be laying around, because if you do take a hit, the conductor moves around. Mechanical protection if it's an area where someone get hit with a lawnmower or trip over it and so forth. You always want to go in as straight a line as practical, and if you have to make a turn, you want to have very gradual, gradual radius bends in it. The intersystem bonding termination where present, you can connect your system to that. And then again, there's alternatives. Not all of them are recommended, even though they're code compliant. The bonding conductor or grounding electrode conductor can be run inside or outside the house. If your service ground is, your panel is on one side of the house and all your antenna lines are coming in from the other side, you don't have to go all the way around the outside perimeter. You can run a grounding conductor through the basement, or if there's a crawl space. And the bonding conductor, again, has size requirements, except if you're bonding between electrodes, then it goes up the size to 6-gauge copper, and it has to be copper, not aluminum. They allow a single bonding conductor, grounding electrode conductor permitted but not recommended for protection and operating purposes. Again, you should try to keep the functions separate and then just bond them together. Where you bond electrodes, as noted above, 6-gauge copper is required. And this would include if you are bonding your, where you come in with your cables and you have a ground electrode there, you bond that to your service ground. Okay, here it does make specific reference back to the Article 250.70 as far as termination method of the connections. So that's one of the few places in Article 800 that it makes reference to the earlier parts of the code that then have to apply. Okay, transmitting, receiving installations. We talk about the conductors and lead-in conductors sizes. And again, I'm just going through this just so you know it's there. if you're interested, later on here, there'll be a link to the NFPA. There's a site where you can get free access to the National Electrical Code and see specifically which, parts of it may apply to your, depending on what kind of conductors you're using. The clearances, 3 inches of clear building surface, beyond insulating supports, unless if it's in a continuous metal shield, then you're good. Again, these are all just additional, if this, then you don't have to do that kind of thing, the ORs. Antenna discharge unit, it's an antenna discharge unit is not a lightning arrestor. It's really to eliminate static buildup. But the good news is the exceptions they provide, where the lead-in is protected by a continuous metal shield that's grounded with a conductor in accordance with 81058. An antenna discharge unit or other suitable means is not required. Okay, so if you have coax and you have a ground connection around the shield where it comes into your house, you're good. Again, just more specifics on grounding and bonding conductors, the sizes. Again, the code, it can be a little difficult reading it, but as I said, it's easy. Just I said you'll have the link in a little bit. So you can look at it. You can see what parts of it. It's really 810 that you have to look at. But I would recommend you look through all of Article 250 also, because it's the biggest section of the code, but it's on grounding, and there's a lot of good information there just for general purpose. This is where there could be a concern, and this is more for like people who homebrew things. There may still be some out there. Transmitters shall be enclosed in a metal frame or grill, or separated from the operating space by a barrier and so forth. Requires all external controls to be grounded and requires interlocks. Now, one thing about the National Electrical Code is it does not apply to the internal construction of listed equipment. If you have a purchased piece of radio equipment and the manufacturer has already had it listed, basically then the local authorities have no real say over it. It's considered okay the way it is. Okay, for more detail on the code, you can go to the NFPA site. It's the nfpa.org/codes and standards free access. Even if you just go to nfpa.org, there'll be links to the free access. They make it a little difficult to find, but if you go through it, you'll find it. And then NFPA 70 is the National Electrical Code. If you're really looking to get a lot of good information on the code and how it applies to grounding and so forth, a great website is mikeholt.com. He's got a lot of good, he has the code forum. He has a lot of forums, but there's a code forum which gets into a lot of the code related questions, and many of them are directly related to grounding because there's always a lot of questions. Just this your typical, your antenna, you have a lead-in wire, you have a discharge unit if required. You have the ground electrode for the antenna system that's bonded to your service ground. Then you have your service entrance equipment. Lightning protection, again, it's a whole separate topic by itself. It's there's a different NFPA standard that covers it, not NFPA 70. Lightning systems require different ground electrodes, 10 foot in the ground instead of 8 foot. But the different kinds of air terminals, chimney air terminals, copper air terminals, and the amateur radio station air terminal. Yeah, this fortunately, this one never took a hit because the connections were not very good to the minimum grounding facilities that were provided. Protection zone. A lot of times you'll hear talk about the cone of protection. It's been debunked. It doesn't really work, nor the double mast cone of protection. Now most is based on the so-called rolling ball method. We have this 150-foot rolling ball. and anything within that shaded area is considered protected. Keep in mind, lightning will do whatever it wants to do. So lightning hits the side of the Empire State Building sometimes, doesn't always hit the highest point. So it's best to be prepared. There's some empirical calculations behind it that came up with these numbers. So it's kind of like fitting the points to the graph after the fact. But there is some math behind where they came up with some of the requirements for the rolling ball. But in this case, this is a very tall, skinny structure, and you would expect that as long as you had an electrode at the top of it, you're protected. And yet, the chunk of the parapet there that's blown off from the lightning strike, and if you look, you'd see with the rolling ball, there's additional areas that would need to be protected by electrodes, air terminals. Best thing, if you know there's a bad thunderstorm coming, to unplug things, ground all your antenna leads. It's best practice if you're not using your antennas to have a grounding provision. It can be a switch that puts them in the ground position when they're not used, or you can disconnect them, put them on, put a bunch of dummy coax connectors on a ground plate and just screw them into that. So you have that protected, because you can have, just from induced voltages from a nearby storm, thousands of volts build up on your lead, and the coax arcing across from the center conductor to the shell. In summary, the ground rods should be spaced 1 to twice the length. Better to go longer than more rods where possible. Ground resistance as low as possible, not more than 25 ohms. Unless you have a really critical application, you don't have to go too much beyond that. You want to ground the antenna at the roof or tower, low point of vertical cable drops before entry into the building. And any metal object within 6 feet of the ground system should be grounded to the ground system. And you want to avoid gas piping with your grounding conductor. Avoid sharp bends, and you want to make sure the ground path is guided, is to the earth. You want to bond and ground things, and then bond everything together. And again, we talked about not having it so that all grounds have to be disconnected to remove one other piece of equipment. If you have any equipment that has 2-prong polarized plugs, sometimes the receptacles with use get worn, and you can actually put it in the wrong way. So always make sure they're going in the proper way. You should check your ground system often. Check the connections, check to make sure nothing got damaged, that it's still there. And although they have like clamp-on type meters for checking ground resistance, they're fairly cost prohibitive for the individual amateur. But if you know someone who has one you can borrow, it's one way you can take a baseline reading when you first install your ground electrode system, and then you can do follow-up readings, see if there's any change. Okay, there's an old military handbook that should still be available online if you do a little searching. That has a lot of good information. There's some old information that may have been superseded, but it's still not too bad. And then the Motorola Bible, if you will, that also you can find sometimes on online. And now, any questions?
For your presentation.
I've got a question.
Okay.
This is Jack, KK6YOG. Is there any kind of grounding needed for portable, QRP HF operation if you're up on a mountaintop or something? I mean, maybe get down from the mountain, right? But is there any? Have you seen anything about that, or heard anything about people grounding in that kind of situation?
If you're going to be operating on a mountaintop, especially if you're in an area where the so-called isocuronic level is high, a lot of lightning strikes, you'd probably best to put a ground rod in the ground and tie everything to that. Just not so much for a direct strike, because if you get a direct strike to your antenna, the chances are it's going to be spectacular. But there'll be a lot of nearby strikes, and it could be a lot of, if it gets close enough, you might have a ground potential rise that you have to deal with. So it's best to protect the equipment. Yeah, mountaintops can be a little dicey. And there's no real requirement. Obviously, the code doesn't apply to portable operation like that, but it's it's not a bad practice to do that. And the biggest problem is depending on the terrain. If it's very rocky, you may have difficulty. You could have a plate type thing that you could probably spread out on the ground, would just give you like at least a capacitive link to the ground. And if you're in soil, it's difficult to remove the ground rod once you put it in. There are ways around that. I mean, I use for the field day for not so much ground rods, because where we operate, we can usually get them out fairly easily with a twist of a pair of ice grips. But for some of the guy line stakes we put in, I have an old slide hammer that I welded a pair of ice grips onto the end of it, and this way it pulls things out of the ground real easy.
Okay, yeah, thank you. Would that, I mean, along the lines of field day operation, would you recommend doing something like that if you had a portable generator as well?
Yeah, we tend to do that just to be on the safe side. It's and again, just to but we run our site. We run comm links between the different stations for logging to a service. So we are kind of intertwining the different stations. So it's good to have a common ground reference.
Copy that. Thank you.
Okay.
All right, perfect. Yeah, great presentation. I don't know if you want to send me over the slides. I can disperse it to anyone who watched the presentation or anything like that, just so they can get a link and follow along if they want to in the future.
Sure, I'll email it to you. Yeah.
All right, sounds good. You want to stop the recording, Kevin, or any message to the viewers?
Well, we did.
Okay, pretty well. Oh, that part.
So let's see. So the hopefully it'll pique your curiosity. It's because once you start delving into it, you kind of get down the rabbit hole with the grounding, and especially if you get into lightning protection at all.
Gas discharge tubes are pretty fascinating. At least I know. Just looking at them on the basics, but one day.
Okay. Anything else?
I think that's it.
Oh, right.
Yeah, thanks so much for presenting. We really appreciate it.
Okay, glad to do it. I'll email that PowerPoint to you, Matthew.
All right, perfect. And then Kevin. All right, Jack, 8 minutes.
So, hello, my dear children. So before we can re-register the club for the next academic school year, we need to submit new bylaws because a lot of stuff has changed. I ported over our old bylaws into the new bylaws template for the ASI clubs. There were a couple of additions that were made from kind of some areas of concern or kind of areas that were unclear previously. So we tried to kind of add in some stuff that made it a little bit clearer, and we also removed some sections that are no longer relevant due to changes in ASI procedures. Essentially, what we're going to do is we're going to go through the changes that we made, just so you guys are aware of them, and then we'll have a voting period for about a week that will be open for people to go in and approve the changes that have been made on the bylaws, and essentially just kind of vote on approval, and once you have a 2/3 approval of the bylaws, I'll go ahead and do the final formatting, final draft for ASI, so we can get that submitted, approved, and we can get our club re-registered with the new officers. Scroll down.
Scroll down to the.
Essentially, scroll down to where we have the stuff highlighted in green, because that's really what's. Okay, so first, the way it's set up, anything that's in green is something that's been added, anything that's in red is something that's getting removed. So under the officer positions for duties, we added that the officer, some of the officer duties are helping coordinate training of new club officers and organizing speakers for general meetings. And if they're unable to do that, that gets delegated to other officers. For the vice president treasurer positions, we also added in having knowledge of ASI procedures for the main fact that vice president can fill in for the president role if there's a need for it, and then the treasurer is dealing with a lot of the ASI bureaucratics as well. So it's good to have good knowledge of what those procedures entail. To the treasurer duties, we also added beyond just keeping track of the budget, they should report the club financial status at officer meetings, as well as helping or managing our internal accounting system to promote kind of long-term financial health for CPARC and make sure that we're able to kind of continue doing projects into the long term, if you will. Are there any questions by anyone so far? Cool. This is kind of the main section that we added in. So we added a section for transition of officers. And this one essentially is just stating that the results of the election should be announced as soon as the 24-hour voting period ends. The reason why this is new is we used to do our voting at meetings on Thursdays and then announce the results right away. With the new Cal Poly Now system, we're actually doing ballot election forms on the Cal Poly Now system over a period of 24 hours. And then once that period ends, the results are announced. The other new thing is that the transition of officers should take place by the end of spring quarter or start of summer quarter, whereas usually we used to do this at the start of fall quarter. The reason this was added in is so that we're able to kind of continue our activities during the summer. If we have officers who are graduating or in positions of leadership, for example, myself, who is currently president or treasurer, if we do the transition of power at the end of spring quarter, we'll still be able to do PRFs or events over the summertime and kind of do room reservation and whatnot during the fall versus having to wait for approval from ASI to start doing that from the officer transition. We also added in a section for academic probation. There wasn't really a clear section that covered this. It kind of fell between a few different sections, just made it a little bit confusing. So the way we set it up for academic probation is if the president falls into academic probation, the vice president will step in as president for the quarter until the president is out of academic probation, hopefully by the end of that quarter. If the president ends up in academic probation for more than a quarter, then we'll end up having elections for a vice president to fill that role for the next quarter. Additionally, if the president is in academic probation on spring quarter, then the vice president will just fill that role till the end of spring quarter when we redo elections for the next academic school year. If the vice president also happens to fall on academic probation along with the president, then a vacancy election shall be announced and we'll hold a open forum at the next club meeting for people to run and nominate themselves. And then we'll do the 24-hour voting period on the Cal Poly Now for a new officer to be elected. For all kind of AP fill-ins, the position is a temporary one for the quarter, or until the president gets out of academic probation. If they don't get out of academic probation or it's happening in spring quarter, then whichever position ends up going unoccupied for the second quarter will have an election to fill that position. For treasurer, it's a little bit different. For if we have the treasurer end up on academic probation, they'll hold a temporary vacancy election in the same manner as we did for the president, if president and vice president end up on AP. And then if it happens on spring quarter, once again, copy that wrong, but if the academic probation occurs in spring quarter, whoever runs will go until the end of spring quarter, and then we'll redo nominations. Mark, this is something we need to fix.
Then we get it later.
Later, just add a comment to fix that. Is that kind of clear for everyone so far? Let's see. Next section is officer vacancies. So this is what we had before we added in the section for academic probation specifically. So this one is stating if the club lacks a president, then the club advisor will be the person in charge of holding an election or kind of announcing that and making sure that that happens at the next scheduled club meeting. If it's any other position that becomes vacant, the officer body will hold an election at the next meeting, and the president will be in charge of running that election. All voting is to be done on Cal Poly now, whereas previously it was done during the meeting. This allows anyone who is unable to attend the meeting to also participate in the voting process. The parts that I was removing is I was removing the voting body to elect the vice president and secretary specifically from the club advisor, because this is these two are not required positions specifically per ASI. Only president, treasurer, and a club advisor are required for a club to be registered via ASI. So if we don't have enough people to have a voting body, i.e. we only have 3 people in the club, then the advisor would just select a president and a treasurer, and that's all we would need. So that's why the vice president, secretary part are getting pulled out from the insufficient voting body section. I also pulled it out on a couple other sections for the same reason, because Cal Poly updated what the requirements are in terms of who is needed to be in office for a club to be properly enrolled.
So we go with this, or we look at something else.
Was there anything else at the bottom? Otherwise, everything else that's in here was, let's see. This was once again the post recall. So recall is if someone's not fulfilling their job or breaking ASI or club rules, and we hold such an impeachment election for them. Once again, I just removed the vice president secretary section from here to update it to the current Cal Poly requirements. The other things that got removed were other officers on the charter having financial authorization. As per ASI, the only people now allowed to sign and even fill out PRFs are the president and the treasurer of a club. So no other officers are able to do this. So I'm removing this wording, or it would be kind of contradictory to what exists. I think that was most of it. Everything else was just brought over from the previous bylaw document, and the only thing that I did was I changed the formatting to match the current formatting in the document. So essentially what we would be voting on are any of the changes that were made, so things that were added or things that are being removed, and anything else would just continue to be set up the same way as it was previously. So yeah, does anyone have any questions, comments, things they maybe want clarification on?
Especially if you're gonna be, well, if you're gonna be here this, next year, it's gonna especially affect you, so if you have anything you're confused about. it's a good time to-
I do have a comment on
Yeah.
specifically the academic probation
Uh-huh.
section there. I feel like that's something that, people might not want to disclose. It is private information and sensitive information. I would just leave it up to, and this is just my opinion, but I would just leave it up to like if the president has to take a quarter off for whatever reason.
Mhm.
Because like not everyone wants to announce to the world that
Yeah,
they're on
that's okay.
academic probation. Like I didn't want to, but it was something that happened and something that I needed to disclose.
Yeah.
And like not everyone wants to disclose that because it's not just the officers that hear that. It's everyone in the club and it's also people that are seeing like information in newsletters and such.
Gotcha. Yeah, that's a good point. I'm trying to figure out, I guess, kind of what I would call it to not have it overlap with the vacancy section, like, I guess maybe call it temporary vacancy, potentially.
I
don't
would
know.
just leave it as a note in the vacancy section, like for example, like reasons for taking a quarter off, for example, academic probation, and then leave a
Okay.
note about the ASI requirements that you cannot be on academic probation to be the president or the chair.
Yeah, because the way the vacancy is set up right now is if there's a vacancy, a new person is elected and they're in that position until the end of the year. Unless someone decides to drop out of that position to let someone else kind of continue and re-elected essentially.
Right. I'm okay with like, I think it would be good to maybe just add an exception in for that, like if the president or treasurer needs to take like temporary time off. For whatever reason, like it doesn't even have to be after probation, like if there's, maybe you're having trouble with mental health, or like if you're just having trouble at home and need to return home for whatever reason, and you need to take time off of school. I don't think it's often sensitive information. The
Yeah,
reason why you're taking time off, so I don't think it should be,
Um,
so public.
should I just kind of keep the section, just call it like temporary vacancy versus kind of permanent vacancy? And have it two different protocols, or do you think I should just add a sub-note in the vacancy?
The exact title can be up for discussion. I would be okay with temporary vacancies.
I'm just trying to figure out if I can kind of just change the naming and keep the way the section is set up that way, or if I need to try and combine it into the vacancy section. Because it might add more confusion to the kind of vacancy election,
Got it.
like a permanent versus a temporary one.
Right, yeah. I totally understand that as well. And this is just my opinion.
No, yeah,
of course,
no,
by the
it's-
way.
it's
Like, if
great.
it's something that other people disagree with, do make sure to give a word in there.
Yeah, I agree with Helen. There should be some sort of, you don't need to explicitly need to take.
Yeah,
leave
no,
for
totally.
positions, justify it, or explain it, if you're not comfortable sharing.
Yeah, I just know there was some confusion this quarter over, like, I ended up on AP for winter quarter. And then it went where we had an election and Matthew stepped in as temporary replacement. And it was kind of the idea that once it got out of AP, I was gonna step back into the president role, but to do that, we needed to then have another election, which kind of delayed things by another 2 weeks. For kind of just retransitioning everything, which when we were in the middle of kind of doing PRFs and ARDC stuff, kind of made everything again. But I do agree on changing kind of the AP to a more general kind of temporary vacancy for whatever reason. For kind of AP or whatever, I think that's a good idea. So people don't have to specify, they could just say, this could also be valid for something like if someone's going to study abroad, potentially. It could also fall under these categories.
Yeah, that was all I had.
Oh, yeah, totally. It's a great point. Anyone else? Yeah, I'll reword that section when I get home tonight, to make it more what's the word? Comprehensive, for general temporary vacancies versus a permanent one. I can do like, if a vacancy is expected for greater than a quarter, then do permanent permanent vacancy procedures and whatnot, kind of make it more broad. That's kind of all I had. Comment, Jack? Probably tomorrow morning or later tonight. I'll send out an announcement on the Discord announcement. I'll also send an email to Kevin to send out on the Gmail mailing list when that happens as well. Voting will be open on the Cal Poly now to any currently registered club member. The way it'll probably be set up is it'll just be kind of here's the club bylaws, read through it. I'll have a list of changes that are on the front page as well, so people are aware of kind of what it is that changed. And then just kind of do you approve of this or do you not approve of this? And then probably have kind of like a why section so that they can, if people have a lot of suggestions or if we get kind of common consensus on something that people don't like, we can come back, revisit that, rework that section and then put it out for a vote.
Thanks for watching.
Like and subscribe.
If you have any questions, contact information is below. Enjoy your life. This is the last meeting this year. So thank you all who have been things happen and coming out and having fun and enjoying life. And see you at the celebration next year.
All right.